Class 10, Light, Reflection and Refraction is one of the very important chapters that has a good weightage in the final examination. It is a common observation that students face a little bit of problem in this chapter. However, this chapter is not that difficult if you can remember a few key points which we'll be discussing today. So without further ado, we present the chapter of light, reflection and refraction in just 10 minutes. The first thing that you need to remember is that light seems to travel in straight lines. Now you can see here three figures depicting the same. Mirrors and lenses are systems that form images of objects. In the left side, you can see an image formation by using a mirror. Whereas on the right side, you can see an image formation by using a lens. Images can either be real or virtual depending on the position of the object. On the left side, you see a plane mirror in which a girl is seeing a virtual image. On the right side, you can see a concave mirror in which we can see a real image. All reflecting surfaces obey the laws of reflection. So what are the laws of reflection? There are two parts to it. First, the incident ray, the reflected ray and the normal at the point of incidence are coplanar. Second, the angle of incidence equals the angle of reflection as shown in the figure on the right. To deal with curved mirrors and lenses, we use the new Cartesian sign conventions as listed. It contains 4 points. The first one is that the object is always placed to the left of the mirror or lens. This implies that the light from the object falls on the mirror or the lens from the left side, as you can see in the figure shown below. The light from the object is incident from left to right. Second one, all distances parallel to principal axis are measured from the pole or the center of the mirror or the lens. Here the pole of the mirror is marked V and all distances are measured from the point V. Third point, all distances which are measured parallel to the right of the origin are taken to be positive, whereas those which are measured to the left of the origin are taken to be negative. This is shown in the figure with the red arrows showing positive and negative. Distances which are measured perpendicular and above the principal axis are taken to be positive. See the upward arrow on the right side, and distances measured below the principal axis are taken to be negative. This is shown in the left side downward arrow and the right side upward arrow. So once we have understood the Cartesian sign conventions, we now go ahead to see the mirror formula. The mirror formula relates the object distance, the image distance and the focal length as 1 by b plus 1 by u is equal to 1 by f. The second relation that you should remember is that the focal length of the spherical mirror equals half of the radius of curvature. Also, magnification produced by the spherical mirror is the ratio of the height of the image to the height of the object, that is, hi by ho equals to minus v by u. Now that we've seen reflection, we now go ahead to understand refraction, which is the bending of light across the interface between two media. Now when a ray of light travels obliquely from a denser medium to a rarer medium, it will bend away from the normal, whereas if it travels from a rarer medium to a denser medium, it will bend towards the normal. This is illustrated by the figure shown below. So why does bending of light occur? Bending of light occurs because the speed of light is different in different media. In vacuum, light travels with a huge speed of approximately 3 into 10 to the power 8 meters per second. To characterize each media, we define the refractive index of a transparent medium as the ratio of speed of light in vacuum to that in that medium, and this is written as mu is equal to c by v, where c is the speed of light in vacuum and v is the speed of light in the medium. Refraction is governed by the laws of refraction, in which we have again 2 points. The first one states that the incident ray, the refracted ray and the normal at the point of incidence are all coplanar, and the second one is basically the Snell's law, and it states that for a given color and for a given pair of media, sin I by sin r is equal to mu2 by mu1. Here, I is the angle of incidence and r is the angle of refraction, and both are shown in the figure on the right side. One interesting feature of refraction is the case of a rectangular glass slab, which you can see in the figure. In the rectangular glass slab, the refraction takes place at both the air-glass interface and the glass-air interface. The unique feature of this refraction is that the emergent ray emerges parallel to the direction of the incident ray. Refraction also occurs in lenses, and the governing equation for lenses is the lens formula, which is 1 by v minus 1 by u is equal to 1 by f. And this is relating the object distance, image distance, and focal length. All these quantities are marked in the figure shown below. For lenses, the magnification again is m, which is equal to hi by ho, which is equal to v by u, that is, the ratio of height of image to the height of object. And finally, we also characterize the lens by its power, which is defined as the reciprocal of its focal length. Its SI unit is diopter, and the formula that governs it is P is equal to 1 upon f. We hope this short video will help you get a quick recap and revision of one of the most important chapters of your science syllabus. If you found it useful, please do like, share, and subscribe. Tag High Inc. is a Samsung-funded education technology company with headquarters in South Korea and an office in India. Our offerings include clicker-based classroom response systems and AI-powered self-assessment solutions. We provide our solutions under the ClassSaathi brand in India and under the ClassKey brand elsewhere. Do check out our website using the link given in the description below. We'll be coming up with more awesome videos for you in the coming weeks. Till then, take care and keep learning.